Hi, I am Tannay Jain and I will be solving the question given to us for Maths Homework 2.
So the question given to us is evaluate the integral by making appropriate change of variable. This is the question where R is a trapezoidal region with vertices uh, 1 0, 2 0, 0 to 2 and at point 0 1. So I've already taken the opportunity and have made the trapezoid using these points which can be shown here. So the parallel lines are from 1 to 1 and from 2 to 2. Okay, so to make this question easier, we will change the variable in the initial steps itself. So we will be changing y minus x and y plus x. So let's give them variable u and v, where u is equal to y minus x and v is equal to y plus x. So now the next steps would be to find the limits. To find the limits, what we can do is, as you can see that these are two parallel lines. First we need to take out the equation of the line of these two lines. So I'm calculating this mentally. We can see that the y-intercept is at 1 and we will take it out in the form of y is equal to mx plus c, where c is 1. M will be negative because of the negative gradient. So the one equation of line is y is equal to minus x plus 1 and the other one would be y is equal to minus x plus 2, which again can be rearranged in the form of where y plus x is equal to 1 and y plus x is equal to 2. We see that y plus x is v. So from this you can see that the limits for v are 1, where it is higher than greater to v, and lower than 2. This was the easy part. However, the next part where we have to find the limits of u will be a bit more difficult. So to take out the limit of u, we see that the other two lines where x is equal to 0 and y is equal to 0. So we need to express x in terms of u and v. Then we can solve for x in terms of u and v, and we can get where y plus x is equal to v and y minus x is equal to u. When we basically now we subtract them, so we get that 2x is equal to v minus u, which can again be written as x is equal to v minus u by 2. From this we get to know that one of the limits where u is equal to v. Now what we do is we take out the other limit in terms of y. What we can do is y plus x is equal to v, y minus x is equal to u. We can straight away add these, so it becomes 2y is equal to v plus u, y is equal to v plus u by 2. And now again, when we consider y to be 0, we can see that u will be equal to minus v. To explain whatever we have gathered till now, we'll use the graph which I had made initially. So we can see that for v where the limits are 1 to 2, we see that the integration will be diagonally, which is it will be from 1 to 2, and it is contained by these two lines. However, for u, it will be from the lower right to uh, towards the top left. So the integration is like this. Now going ahead and solving the question. um, Now we will add all the variables we have and rewrite the new limits. 2 1, this is for v, and for u is equal to minus v and v, and it will be cos u v, and then dA can again be written as du dv. In this we will also be using the Jacobian matrix, which basically represents the differential at every point of the function which is being differentiated, and this is always in mod. So first we will take out this. So J is it's basically a matrix, and it's a determinant, it's a square matrix. This will be del x by del u, del x by del v, by del y by del u, del y by del v. Now basically to get the numerical values, we can use these two when using when del x del u. So del v becomes a constant, and it becomes a constant, and this is u, and it becomes 1. So del x by del u will be negative half. Now again del x by del v, in this v in this u becomes a constant, so it is taken out. V becomes 1, so it becomes half, and we'll use the similar steps for y. For del y by del u, del v becomes constant, we take u, so this is half, and then again we do the same for del y by del v, which is again half, which when solved, it's negative 1 by 4, and then I straight away written it, 1 by 2 into 1 by 2 minus 1 by 2 into 1 by 2, which is negative 1 by 4 minus 1 by 4, which is half. But as you can see that that j is in mod, so it, when considering this in the function, it will be positive. So I once again want to write down everything. 2 1 is for v u is equal to minus v cos u v, and we've taken out the Jacobian, but we'll again once write it in its matrix form. Half du dv. Sorry for the weird cut. Now continuing the question, we know that the j was half, and we've integrated it once, 2 1, and cos becomes sine, and because we integrated in terms of u first, so u by v. So where v becomes a constant, this is divided by 1 by v, and then v plus negative. We still have to integrate in terms of v. Now we can go ahead, half to 1 sine u by v into v, v negative dv. Now actually putting in the values, sine, this will become 1 and this is become minus 1 v dv. We know one thing, that when sine has a negative theta, it can be also written as negative sine theta. We do the same here, which leads to us having 2 sine 1, as this becomes positive v dv. Now this becomes a constant and it comes here, and because there's a 2, so it becomes sine 1 to 1 v dv. Yeah, now again now this is just simple integration, this becomes sine 1, now this will be v square by 2, and we have 2 and 1, sine 1, it becomes 2 into 2 4 by we'll just take this 2 outside, 2 4 minus 1, which is this becomes 3, so it is sine 3 1 by 2. So this is the answer.